is not lie on the root locus of a system. See, the open loop transfer function is given as u of s h of s. If we plot root locus for the given open loop transfer function, the poles are located at 0, that is origin, -1, -3. Here, the point on the real axis is going to be in the root locus. To the left of it, to the right of that particular point, the number of poles and zeros are going to be odd. Suppose if we look from here, this portion is going to be in the root locus and this is going to be in the root locus. This portion is not going to be in the root locus, that is -1 to -3. So -1.5 is not going to be in the root locus, hence option B is correct.
This table for k equal to, he has given a block diagram. Okay, in that diagram we have gain k. We have to find out when this gain k is stable. For what value of k it is going to be stable, the system. Okay, now what is the characteristic equation we have to find? From that we can analyze the root locus, or you can also find Routh-Hurwitz criteria. It is better to find Routh-Hurwitz criteria, it will be easy. Okay, now what is the total block transfer function? Total block transfer function, if you reduce this one, okay, we will get it as k by s square plus 0.1 ks plus k. This is the overall transfer function of this block diagram. Okay, now what is the characteristic equation here? S square plus 0.1 times of ks plus k equal to 0. So this is closed loop transfer function. Okay, now what is Routh-Hurwitz criteria? From Routh-Hurwitz criteria we can find this one as s square s power 1, this is s power 0, alternate terms 1 and k, this is 0.1 k. So what is this one? Is equal to k. Okay, when the system is stable, when k is greater than 0, or you can say 0.1 k is greater than 0. Okay, or this is also, it is founded as k is greater than 0. So only one condition it is there. When gain value is greater than 0, the system is stable. When gain value is equal to 0, then system is marginally stable. This one is stable. When gain value is less than 0, then this is unstable. Okay, these are the three conditions which is possible for the gain value of k. So answer option is A, since we have to find out the condition for stability. Okay. Response of the system is shown in figure if the pole zero plot is of the form. Okay, now he has given the 4 options and there are 2 poles in the left hand side. So, okay, this is the real axis and this one is j omega axis. Now let us take this is minus sigma and the pole at these points is j omega. So what can I write this expression? Okay, I'm doing it here. What we can write that expression? These are imaginary poles having real part. Okay, so I can write this one as s minus or s plus sigma whole square plus omega square is equal to 0. These are the poles we are having. Okay, so what can I write from this? S1 comma S2 is equal to minus sigma plus j times of omega. Okay, or now this is the function. What we can write? The inverse Laplace transform of this one, j times of omega square. If this is the response we are having it. Now what is h of t here? H of t is equal to, I can write this one as e power minus sigma t into, okay, it is multiplied and divided by omega. So this is by omega into omega by square plus omega square is sine at. So sine omega t. So from this response, what we can write this one? This is e power minus at. So these are damped oscillations. Okay, or you can say decaying oscillations with respect to sine term. Okay, so this is not damping, this is not reducing to 0 at infinite, so this is not the option. Similarly, he has given the other 3 options as like this. This is reaching infinite and infinity, so this is not the correct answer. So what about this option A here? We are having e power minus at function. E power minus at function response is a decaying one. We have assign response. Okay, so what is the joint of these two response? What is the combined response of these two? Option A is the correct answer.
A random variable y equals to the summation of identically independent random variables, and each random variable characteristic function is 1 by theta. Then pi y of omega is, here y is summation of IID variables, IID random variables. So the characteristics function of y is nothing but the product of individual characteristic function, that is pi y of omega is equals to pi x1 of omega to pi xn of omega, which is nothing but 1 by theta, 1 by theta up to 1 by theta, which is nothing but 1 by theta whole power n. That is option B is correct. Expectation of xn is given as 2 and h of n is given as 2 power n u of n. We have to find the mean of y of n, that is expectation of yn is nothing but h of z, z equals to 0 multiply with 2. H of z is given as z by z power z minus 2 into 2 at z equals to 0. That is z equals to 1. We have to substitute. So 1 by 1 minus 2 into 2, which is nothing but minus 1 into 2, that is minus 2 is the correct answer. That is option A is correct. Option A is minus 2 here. This. Consider a random process x of t given by x of t, which is equals to a cos omega t plus b sin omega t, where omega is a constant and a and b are random variables. If a process stationary, then for a stationary random process, the mean should be constant. That is, expectation of x of t should be constant. It should not depend upon time. So expectation of a cos omega t plus expectation of b sin omega t. So expectation of x of t is independent of time if and only if both expectation of a as well as expectation of b are equals to 0. That is option C is correct. Option B is correct. Which of the following true and are false statements? Statement P. The radiated power of R by 4 monopole is half that of R by 2 dipole. Statement Q. The radiated resistance of R by 4 monopole is more than that of R by 4 dipole. See, comes to statement P. The radiated power is proportional to the radiation resistance. The radiation resistance of R by 2 dipole is more than that of R by 4 monopole. Hence, the radiated power of R by 4 monopole is half that of R by 2 dipole. Hence, statement P is true. Comes to statement Q. The radiated resistance of R by 4 monopole is more than that of R by 4 dipole. It's not true because the radiation resistance of R by 4 dipole is more than that of R by 4 monopole. Hence, the statement Q is false. That is, option B is correct. Following transmission line shown below, the voltage at VAA dash will appear at VBV dash after a time interval of. See here, this is the DC signal, that is U of t. Here length is 300 meters. That is, lambda is equals to infinite because frequency is 0 for the U of t. If frequency is 0, so phase velocity is approximately equals to the velocity of light. So time is nothing but L by Vp, which is equals to 300 divided by 300 into 10 power 6. That is 10 power minus 6 seconds, which is 1 microsecond. That is option B is correct. Group 1 with group 2. Coaxial cable, parallel wave transmission line and microstrip line. In coaxial cable, shielding is provided. Hence, there is a low electromagnetic interference. Whereas parallel wave transmission line is high electromagnetic interference. Microstrip lines are preferred in printed circuit boards, that is PCB. So 1 PE, 2 R and 3 Q, that is option B is correct.